Hello, and welcome to Nodes 2020. Thank you for joining us today. I am Zoe of Semiotics Web. Semiotics Web is an inclusive gathering for anyone interested in discussions and studies related to semiotics web, information architecture, artificial intelligence, machine learning, semiotics, semantics, human learning, logic, signs, signals, meaning systems, sense making, web science, thinking, language, communications, knowledge systems, and wisdom systems in digital and web spaces. I'd like to introduce you to our speaker, Christophe Willemsen, CTO at GraphAware, who will be presenting on Neo4j security in action. To give you some background on our speaker, Christophe is CTO at GraphAware, the world's #1 Neo4j solutions and consultancy. Christophe implemented enterprise Neo4j-based solutions in different industries across the globe. He now focuses on the research and development of GraphAware expertise in various strategic Neo4j-related technologies, ensuring GraphAware remains the worldwide go-to graph company. Thank you and welcome, Christophe.
Thank you very much. I'm Christophe Willemsen, CTO of GraphAware. I'm very excited to talk to you about Neo4j security today, a very exciting topic to make your Neo4j deployment more secure. A small outline for today. I will give a brief introduction to security and how we will use the STRIDE threat model to harden and evaluate the security of a Neo4j deployment. So let's start with security introduction and the STRIDE model. The STRIDE was created by Microsoft as part of the process of threat modeling. So it helps security engineers to reason and find threats into a system. So it includes a breakdown of processes, data stores, data flows, and trust boundaries. And it is used by security experts to answer the question, what can go wrong in the system we're working on, right? So STRIDE was made to put security as part of your application development lifecycle. It's not an artifact, right? We put security upfront in the development and deployment of application, databases, and systems. STRIDE, in a nutshell, is a mnemonic for security threats in 6 categories. So the S stands for spoofing identity. The second, T, tampering with data. R for repudiation. I for information disclosure. D for denial of services. And E for elevation of privileges. We will go over each of them during the hands-on, and we will evaluate for each category what are the threats, but also how you can mitigate these threats. So let's spin up a Neo4j server and find how we can make it better for security based on each of those categories. So let's write a new password, for example, pass. So here I have a deployed Neo4j server, of course on my local machine, but it represents the deployment of Neo4j server. And let's take the first category of the Stride threat model, S, for spoofing of identity. What does spoofing of identity means? It is, for example, stealing the identity of someone and using it for malicious purposes. So there is spoofing of identity every day, for example, stealing credit cards. But in terms of Neo4j server, I can actually go anywhere in my office, and if somebody is not behind his computer, but the computer is turned on, I can access his Neo4j server and try to find the password to his Neo4j server, and then log into that Neo4j server with his own account. By default, and not a lot of people know this, Neo4j is storing the credentials of the connection in the browser local storage. So if I open the developer tools of my browser, let me zoom, and I go to local storage here, I can see there is information that Neo4j is storing into the browser to make the user experience more delightful. Right, so you can see the settings for the history of the queries, you can see the UDC, the styling, but there is one very sensitive setting, which is neo4j.connections. It stores the connections to the Neo4j servers he knows, and if we unwind the connection here, connections by ID, we can see our running server here, and it stores in plain the password of my connection. Right? So this means that I can, if I find a user of Neo4j and his laptop is unlocked, I can actually easily go to his browser and find the password of his Neo4j account. So let's harden this by disabling the storing of the Neo4j password in the browser. To do so, you have to add this setting into the Neo4j configuration. Right. So don't worry, all the settings and queries we will see today will be shared at the end of the talk. So I will open the Neo4j configuration file of my deployment. Here, graphs, nodes 2020, configuration, neo4j.conf. And I will go at the end of the file and I will add this setting. Here, security settings, and I will add this setting. I save my configuration and I restart my Neo4j server. Neo4j is restarted. And if I refresh my browser, here, I can go back to the developer tools, take the connection, and I can see that now the password is not stored anymore in the Neo4j, in the Chrome browser. So this was for the S, spoofing of identity. Then comes the T, for tampering with data. What does tampering with data means? It means that if a hacker can intercept communications between a user and a Neo4j server, for example, HTTP communication, which is not encrypted, he can potentially modify the data of the connection, of the communication, before it arrives to the Neo4j server. So how do we mitigate that issue? Well, it's well known, right, that we have to run databases, actually any deployed application today, over HTTPS, right? So for secure transfer layer. Neo4j, of course, allows to enable HTTPS on the server. So let's see how to do that. Here it will not really represent the real life because I am working on my laptop, but I can simulate this. So I can actually generate here a SSL certificate with a simple command. So maybe I will go to cd dev graphs nodes certificates. Okay, so I will simulate that certificate. I will create that certificate, sorry. So it created two files, the certificate file and the private key, right? Now I have to tell Neo4j to enable the TLS connection on both the VoLT protocol and the HTTPS protocol. So here, what happens is that we enable SSL on VoLT. We say that nodes 2020 is our advertised address, which is a loopback to my local host. We give the path to the key and the path to the certificate, right? And there is one additional thing that we should do is to disable the HTTP port. Here, I will disable it and enable the HTTPS port on the port 7473. All right, so let me restart the Neo4j server again. So we can see here now, Neo4j is available on the HTTPS protocol on port 7473. So I will here go to HTTPS nodes 2020 7473. I have to accept the certificate because this is a self-signed certificate. So default browsers don't accept the certificate. Like I see here, not secure because it's a self-signed certificate, but at least we are on HTTPS. So this means that any communication will be encrypted. Right. So here I am connected to Neo4j over HTTPS. So this means that the connection between a user and the Neo4j server is encrypted and thus cannot be tampered with data. For the purpose of the workshop, I will disable again the HTTPS to run with default setting. Here, all right, and I will restart the Neo4j server. Now, let's take the next category, repudiation. This is one of the most important categories in any Neo4j deployment. So what does repudiation mean? It means that anything that happens to the system has to be accountable to someone. So there is no action where the reply to the question, who did that, is, I don't know. So it's very important. So let's take this scenario. I will create a database in the system. So we'll create, for example, a new database called production, which represents my production Neo4j database. And here I have a simple application that will delete the database from the server. So let's run this. Right, so it completed successfully. Now if I try to log in to the database production, well, my database disappeared. So how can I trace this back to the right person that should be taken accountable for the deletion of a production database? Easy, you will say. Let's look at the logs. So if we see here, Neo4j logs don't log anything about the deletion of this database. So let's look at the query logs. So we'll output all the logs here, and I can see a query started. Let me zoom again. I have query started, drop database production. But this is probably all the information I have. So I know when it was started. I know it was issued by a Java application. This big ID doesn't tell me anything. Yeah, so actually we lost the production database and we don't know by whom and by what application, right? So there is something in Neo4j that is called transaction metadata. This is additional information that you can add to any query that you run against the Neo4j server in order to identify what is this query doing, what is the purpose of this action, and also sometimes who is the user or the application side, right? So this is information that will be appended into these curly brackets here. So you can add any additional information that you need to in order to ensure that you can take everybody accountable for such impactful operation as deleting a production database. Let's use the same query, but with what I was saying, the transaction metadata. So you can see here that we add to the transaction metadata that is here right now, a static map where I add information. So application knows 2020, user, it's me, and the reason is an administrative cleanup, right? So let's create that database again. Neo4j pass, system, and run the same transaction for deleting a database, but this time with the metadata. It completed successfully. Again, the production database is dropped. But if I look this time at my logs, I can see that I have the same operation logged, drop database production. But I know can trace back this operation to someone for a reason in a particular application. So Neo4j query logs are extremely useful for security, right? It's not only for debugging purposes, but it's a huge asset for when you have a security breach. This is the only asset you can really rely on. This is the logs of the Neo4j server. Let's take the I for information disclosure. This is a very big topic. So information disclosure says that a user should only have access to the data that he should access to. So what that means, it is based on the principle of the least amount of privileges. So if here we are using the Neo4j user, which is the administrative user, can do everything. But in production, you don't want to use that user. Application should never use the administrative Neo4j user. You should have dedicated accounts to make connection to the database. So you have control on what this account can do and cannot do, right? To give an example of this concept, we will actually create a database with some data in it. So we'll create database Nodes 2020, right? I will import some data in it. So let me copy that data. So I'm copying that CSV file into the import directory. And I will load the CSV file. So here, this is my query. And we will look at what the data is really. So use Nodes 2020 and insert the data. So we load the CSV file, create persons, create test results, cities, and relationship. The query is completed. We can see it added almost 3,000 labels, created 3,000 nodes, created 14,000 properties and 2,000 relationships. Right. So let's look at the schema. Right. So here, let me zoom. I have test nodes, city nodes, and person nodes. Right. So the person are actually citizens. They live in a city and they have been tested for some virus, whatever virus is trending. So the test nodes contain a result outcome, positive or negative. And the person nodes have two types of information. General information, such as first name, last name, etc., and sensitive information, such as NHS number, which is the equivalent of SSN number in the UK. This is called commonly PII, so personal identity information, right? And for our scenario, let's say that we have a couple of different type of people that will connect to Neo4j. We have lab workers, which will actually just insert the test result of a person into the system. The lab workers should not have access to the personal identity information. The only thing they should do is match a person by ID, create the test result, and connect the test result to the person. Right? Similarly, they shouldn't care about where a particular person is living. Right? So again, least amount of privileges. They should only be able to do something in the graph that they should. Right? So only the things they should do, not other things. Another role that we can have is the role of doctor, where the doctor can actually see the PI and see the results and probably shouldn't care where the person lives, right? And we have also a particular role, which is the IT administrator role, right? So somebody that is taking care that your database is still correct, that can create indexes in case for performance reason. So that IT administrator, of course, should not be allowed to read the PI information, and maybe neither the results. Actually, it should really just be there for database administrative operations. So let's start with this scenario. So we will create our users. So don't worry, again, this repository of queries and configuration settings will be shared at the end of the talk. So I will create 4 users with all a default password, which is pass. Never use pass in production, but it's easy to remember during a hands-on. So I'm creating 4 users. I can actually give access to every role that user will have. So for example, Jane will be a lab worker, Claire will be a doctor, Maria will be secretary, Bob will be a IT admin. So I can create one role for each type of user and then assign users to the role and then give the role access to the Notes 2020 database. But there is an easiest way to do this is that every user in the system, right, by default will get the public role, right? The public role, if I now log in to a Neo4j as another user, so localhost 7474, and let's say I log in as Jane, and my password is pass. All right. So, right. The public role has default access to the Neo4j database, but doesn't see the Notes 2020 database. So let's fix this. We will grant access, it will be easier, on database Notes 2020 to public. Public is the role, right? So every user having the public role will be able to access the Notes 2020 database, right? So let's check back on Jane here. And now we can see I have access to the Notes 2020 database, right? But I have no access to data, right? So now let's take care of the IT administrator role, right? So it should do all the administration command that the admin role should do, but we need to make a copy and then remove privileges that the admin user can do, right? So we will create a role IT admin as a copy of admin, right? And then we will deny access to particular information for the IT administrator. So I will deny the ability to read the NHS number on the person notes in the Notes 2020 database. On the same way, I will deny the ability to see relationship test results. So this means that the IT administrator cannot see results of person. So let's add this here. And let's see if we have something else to do. No, we will add to Bob the role IT admin. Now, if I would log in as Bob, so let me disconnect from Jane, and I will log in as Bob. So I can see the Notes 2020 database. I can see person test, but I don't know. Yeah, I can see person. And as you can see, oh no, this is a, yes, this is a person. I don't have access to NHS number, right? While as the administrator, if I go to the Notes 2020, I can see that any person definitely has an NHS number property, right? So let's go forward we want to create an additional role, which is the lab worker role. And here we will create a full role from scratch. So despite the IT admin, where we started from an existing role, here we will create the role from scratch. So we will create a role lab and then grant on the role lab the ability to traverse all nodes on the graph. We also will grant the ability to traverse all relationship, only the relationship test result in the graph. We can read all the properties of the test nodes. However, we can only read the ID property of the person node. So this means that no access to username, to first name and last name, no access to NHS number, etc. We also need to grant the creation ability of test nodes because the lab worker should be able to add new tests. And of course, connect those tests to persons. So we will grant the ability to create test result relationships into the graph. And we will grant the ability to create any property on test nodes into the graph. So this is a lot of things to add, but it is very secure. All right, so now let's run the role lab to Jane here. And let's connect back as Jane here. So let's disconnect from Bob and log in again as Jane, which you'll remember previously was not able to see any nodes in the graph. Right? Use the nodes 2020 database. And now we can see here, I can see person, but I'm seeing only the ID of the person because I shouldn't see first name, last name, etc. I'm seeing test results, of course. And let's try to add a result. So let's imagine that Jane is finishing a lab result and want to insert it into the graph. She should be able to match a person by ID because ID is the only property she has access on the person nodes. She can create a test and create properties on the test node and connect the test to the person. And here it is created. One label, one node, 3 properties, 1 relationship. Right? So there are many rules and fine-grained solutions that you can apply. So again, least amount of privileges. Users should be able to access and do only things that they should, right? Now, denial of service. So everybody has heard AWS is down, GitHub is down, GitLab is down, etc. because of DDoS attacks, right? So how can DDoS attacks happen? Well, it is when you have too many connections, right? Or even internally, somebody, one of your user, who is creating a query that is taking too much memory and can bring your Neo4j server down and thus prevent access to information to other users, right? So DDoS attacks is not only like trending news for big companies. It can happen very easily, even inside your own organization. Somebody is doing a wrong query and bring your Neo4j server down, which prevents access to services to other users, right? To valuable services. So this is the purpose of denial of service. How to mitigate this? Well, as we saw, there is already Neo4j logs, right? Query logs. So as you can see here, you see the time a query is taking to perform, right? So you can see here, this is the generated queries from the Neo4j browser. But if we see here, create, result, T, etc. So those were very, very lightweight queries, right? So they don't take too much time. But it's very important to monitor, right? So you can monitor, for example, only queries that take above 1 second, etc. So, but not only. Right? So I will run one query. Okay, I will do something. I will enable epoch. We just do cp labs, and then I will enable epoch in the Neo4j configuration. So to be able to simulate a big query here, like requiring a lot of memory. So we'll restart the Neo4j server. And then here I'm logged in as Jane. Perfect. Oh, started. Jane, pass. And then I will simulate a query. For example, I will generate an iterator of 1 million items. And then I will return a map. And I will do with. And then I will prevent streaming. So efficient performance by actually having to order the map. So we'll collect the map, collect as maps, and then I will use epoch.call.sort maps on name to prevent streaming. So I'm running this query, and what is happening, sadly, I cannot make you hear this, but my computer will start actually to cry, right? So I will hear in about 10 seconds that it start to heat and consume a lot of memory. And actually, if I check the memory usage of the Neo4j server, I can see it's already, I mean, I have a big laptop, but it's already at 25 gigabytes, right? So 3.9 non-virtual memory used. So it's a lot, right? So if we think about simple query like this, right? But you see, it's running, and actually it's very unstable for your Neo4j server, right? So if you have 15, 20, hundreds users that are doing unperformant queries like this that can take a huge amount of memory, while your Neo4j server will go really out of memory. So actually, I will kill the Neo4j process, right? So I will kill, and I will actually give a limit to the memory that the Neo4j server can use. So you will see much better what will happen to the system. Okay, so while it's stopping, let's check for page cache. Here, I will give a page cache of only 100 megabyte, and I will give only 512 megabyte of heap. Okay, I will restart Neo4j. I will close this, just refresh the browser, log in again as Jane, pass, and I will run the same query here. Right. So it will spin. In the as a admin, I can go call db. No, of course, Neo4j pass call db.list transaction here, and probably it timed out. Okay, here we can see that this query went out of memory. So I have transaction that run out of memory. So let me start again to, okay. So we can see actually it's also impacting how this query is using. You can see it took more time, right? So it's very unstable to run those type of queries, right? I mean, one is not an issue, but hundreds of users doing the same will be an issue. It will bring your Neo4j server down, and it will prevent access to valuable systems to your users. So how can we circumvent this? And this is, I think, one of the most useful features of Neo4j 4.1 is the ability to control the amount of memory that transaction can use, right? So I will give two settings here. Up. So the global maximum size that all transaction can use as memory. And here, the max size of memory that a single transaction can use. So here I've put for the demo very specific settings, right? But it will show you something first, that you have control on the mitigation of denial of service against your Neo4j server. And you can also monitor this in the logs. So let's actually add these settings to the Neo4j logs here. And restart Neo4j. Log in again as Jane. And issue the same query. But now I have control on how people can actually try to break my Neo4j server. So here we can see the allocation of 42 byte would use more than the limit of 1 megabyte currently using. So actually it reached the configuration I have set for the max amount of memory that can be used inside a single transaction. If we go back to the logs, here we can see, one second, shouldn't be this, logs query.log. Okay, we can see here the time a transaction took, but also the memory usage of a transaction. So of course it was prevented, but it's good, right? So you have control on who or why a person can break your Neo4j server. All right. Now the last one, which will be the easiest one, it's the elevation of privileges. So again, as in the I scenario, so user should only have access to what they should, while elevation of privileges should allow you, as someone who maintain a secure Neo4j deployment, to identify when a user has been granted higher privileges than he has today, right? So let me, for example, use system again. We will create again a copy of the administrator role here. Okay, so let me do this. Create copy of admin as new, I don't know, secure role. Okay, interesting. Okay, I was disconnected. So this is one of the disadvantages of not storing the password in the browser, is that it disables a bit the user experience, but better secure than friendly. So use system and then create copy of admin. Okay, this was not this. This was the title of the query. Okay, the admin already exists, so secure. Now let's ground the secure role to the Jane. Right. So again, something happened in the system, right? So some user because of his role, has now full access to everything in the system. So if I would be a Neo4j administrator or system administrator, I would like to be notified that such thing happened, right? This is very important. And this is actually happening in the Neo4j security log. So let's go here. Let's get logs, security log. Right. So we can see here that the user Neo4j created a role secure as a copy of admin, and the user Neo4j granted a role to the user chain. Right. So you can see actually all the security operations have been logged. So you should take care of these logs, notify people, etc. So this was the last category of the stride model. And this is also the end of my presentation. So maybe it's time for questions. So let me look at the chat. Q&A. Okay. So I probably cannot answer all the questions. I will take the first three. And if you can always reach out to me to goaffair.com, on the Neo4j Slack, or on the community Neo4j forum. So here, first question is, okay, so do I actually recommend to enable all the logs? So also not only the queries that take higher than X amount of time. So this is a good question because it happened to one of our clients recently, where they have all the logs enabled. So any query with all the parameters are locked into the log. So of course, in the beginning, with the ETL process, well, it actually puts the server into out of disk space, right? So it produced a lot of logs during the night because of the ETL pipelines. So, but in a nutshell, yes, I do recommend to log everything, right? So, however, the logs, because if you log everything, becomes as sensitive as your database itself, right? So Linux administration privileges become very necessary to make sure that your logs are securely stored, right? And you can, of course, prevent disk space by using migration, etc. But anyway, I think that disk space is anyway cheaper than a security breach, right? So so you best log everything, because when something happens, and the question is not if, right? It is when something happens. The logs will be the only reliable source that you can use, right? So security forensics this is the first thing they will ask, right? This is access to logs, and if your logs show nothing, then you will never be able to handle incident response, such as a security breach. So yes, I know it will be some administration on Linux side to manage big logs, but yes, this is the most reliable source. Okay, second question. So how does Neo4j deal with brute force attacks? Okay, well, it's an easy question. You can try it by yourself, actually. So if you try to type X number of times in the Neo4j browser, a wrong password for user, well, you will see it will block. So it will back off the login scheme. So you will not be able to try a login operation again for a certain amount of time. So exactly like how an iPhone works. So you cannot use it for 15 minutes, 1 hour, etc. So this is the same scenario. But this is, I think, the only prevention that Neo4j has against brute force attacks. Okay, next question. Is it possible to use SSO for connecting to Neo4j? So yeah, so for those who doesn't know, SSO is single sign-on, such as, for example, Auth0 that you use for connecting to the Neo4j sandbox, or Okta or Keycloak. So no, Neo4j doesn't have a SSO capability to connect to the Neo4j server. However, it's not uncommon that we create custom security extension to Neo4j to connect to single sign-on servers, such as Okta and Keycloak, which is more, or I mean, at Grapher, at least, this is the technologies we work mainly with. But by default, no, Neo4j doesn't have, and it's very important because one of the main mistakes people do is with configuration of the security, but this is what leads to most of the threats in systems. And if you already had to enable LDAP connection to a Neo4j server, you will see it's very verbose and very hard-coded in the Neo4j configuration file. So if you can enable a SSO server to federate LDAP instead of using the Neo4j configuration file, by using, of course, a custom security extension, I think it's recommended because using the Neo4j.conf file for LDAP is not scalable at all. So yes, I think it's about time. So yes, again, if you want the queries that I use, the settings that I use, the how to generate the SSL certificate, you can go to github.com/guapower. You will find Nodes 2020 security repository, and you have all the information in there. And as I stated again, I am available on all the Neo4j community forums. Thank you very much, and have a great day.